Couple of comments. You always have a factor like this, except your parameter's not always t. The derivative, though, is always with respect to whatever your parameter is, right? So the parameter is not always t. X prime and y prime, though, are derivatives with respect to the parameter. Whatever that parameter is. Okay? And I alluded to line integrals over the vector field. It's like you have a planet, you have a gravitational field. It gets weaker as you get further out. Okay? And you've got a path through that gravitational field. So if we go from point A to point B through that field by whatever route we wish to take, you have a line integral. All you got to do is parameterize that path and do a line integral, okay? Now we haven't done a line integral with a vector field yet, but we're going to do that in just a minute, okay? And probably with a gravitational field, so you can kind of anticipate the fundamental theorem in terms of line integrals, okay? And the fundamental theorem just says that if this is a conservative vector field, then the value of this line integral just depends on the value of a certain function here and here. And it doesn't matter what path you take. But if I just write down an arbitrary random vector field, it's probably not going to be conservative. And your integral would depend on your path. Okay?
So if it's within the atmosphere, it wouldn't be conservative?
Yeah. Yeah. And of course, you know, you parameterize in terms of time, so you get your velocity, because your air resistance is going to depend on your velocity, also your altitude. And maybe you choose to ignore whatever the wind is doing, or maybe you just take into account the prevailing winds. Okay? Well, we haven't developed that, so we got to look at an example of a line integral of a vector field. Okay? Now, again, I urge you to understand every detail of this development, because you need to understand it to really understand line integrals and the things that we get from line integrals, okay? And also to understand what we're about to do, which should reinforce what we've done so far.